Okay, imagine a cosmic detective story, a mystery that literally spans the entire Milky Way. Well, a fascinating new paper is trying to crack this exact case. It's titled Constraints on the Lifespan of Intelligent Technological Civilizations in the Galaxy, and the lead authors, Soha Bravar and Shaheen Rouhani from Sharif University, just posted their findings to the archive preprint server. And here's the kicker. They aren't using telescopes to find aliens? Nope. They're actually using the absolute absence of aliens to tell us a really sobering story about our own future. So it begs the question, if the universe is full of life, where is everybody? I mean, we know there are billions of stars in our galaxy, and recent discoveries tell us a huge fraction of them have Earth-like habitable planets. Mathematically speaking, the night sky should be absolutely buzzing with the radio traffic of advanced civilizations. But when we listen, we hear nothing, just absolute silence. You know, this eerie silence actually has a name. It's called the Fermi paradox. Named after the physicist Enrico Fermi, it's pretty much the ultimate unsolved mystery on our cosmic detective board. It's this glaring contradiction between the incredibly high probability that extraterrestrial life is out there and the complete, utter lack of any evidence for it. To really get what the researchers are doing here, we need to talk about something called the light cone. Think of this as a kind of historical census of the galaxy. See, because electromagnetic signals take time to travel through space, looking out into the Milky Way literally means looking back in time. Our current observational window gives us access to about 100,000 years of galactic history. If any civilization was broadcasting out there within that time, those signals should be washing right over Earth today. But decades of searching, zero artificial signals, not a peak. Right, so the researchers took a very logical step-by-step approach to this silence. Step 1. They acknowledge that habitable planets are super common. Step 2, they adopt the optimistic assumption that on these planets, life and eventually intelligence inevitably emerges if you give it enough time, which slams us right into Step 3. Seriously, where are the signals? Well, the authors suggest a pretty chilling resolution. What if, before civilizations can build these massive interstellar empires, they hit a wall? They just collapse. The research considers triggers like asteroid impacts, severe climate change, pandemics, nuclear war, or even rogue artificial intelligence. Notice anything about that list? Yeah, these are the exact same, very real threats that human civilization is currently facing. The authors are basically suggesting that any technologically advanced civilization is going to inevitably face these exact same self-destructive hurdles. This leads us to an absolutely crucial question. How long do technological civilizations actually survive once they discover advanced tech? The researchers didn't just guess here. They used a rigorous statistical approach to calculate this, using the great silence of the universe as their main data point. Now, you might be wondering, why use a mathematical model when we don't know anything concrete about aliens? Well, math allows us to set hard upper limits based purely on what we observe, or, in this case, what we don't observe. And here is the shocking mathematical result they arrived on. 5,000 years. The researchers calculated that if life commonly emerges across the galaxy, the lifespan of a technological civilization is strictly constrained to less than 5,000 years. Because, think about it, if civilizations regularly lasted longer than that, the math dictates they would overlap in time, and our light cone would be absolutely filled with signals. To put it plainly, the math says we are alone in the room right now. Under these optimistic assumptions about life forming, that great deafening silence implies we are essentially the only active broadcasting civilization in the Milky Way at this very moment. The others? They've either already collapsed or they just haven't arrived yet. We could actually map this out on a graph straight from the researchers' paper. So the horizontal axis shows the lifespan of a civilization, and the vertical axis is the expected number of coexisting civilizations. Look at that solid blue line, marked F equals 1. That represents scenarios where life commonly forms. Notice where it crosses the dashed line labeled N equals 1? That dashed line is the threshold where only one civilization exists at a time. That's us. For the blue line to stay at or below that threshold, the civilization lifespan maxes out right at that 5,000-year mark. Now, it's really important to look at the limitations here and ask how confident we should be in this result. First off, this paper was posted to archive. That's a preprint server, meaning it hasn't gone through formal peer review just yet. Second, this whole 5,000-year constraint relies heavily on that F equals 1 assumption, the idea that life is common. But actually, scratch that. What if the jump from simple cells to intelligent tool builders is just a massive 1 in a billion freak accident of the universe? If intelligent life is extremely rare, well, those few civilizations out there could potentially survive way longer without ever bumping into each other. But hey, what if we do want to bump into each other? The researchers calculated that for two advanced civilizations to exist at the exact same time and survive long enough to actually find each other across the vast gulf of space, their lifespans would need to be at least 200,000 years. Let that sink in. That is the minimum survival time required for a successful cosmic handshake. Let's ground this in our own reality for a second. 3.8 billion years ago, cellular life started on Earth. Around 300,000 years ago, Homo sapiens emerged. But we only began our true technological, broadcasting era about 200 years ago. In the grand scheme of the universe, 200 years is literally a blink of an eye. So, if the mathematical limit for a technological civilization is around 5,000 years, we're still incredibly early in our run. Which brings us to the final and definitely the most crucial question of this explainer. Will we beat the 5,000-year clock? The researchers make sure to emphasize that this isn't some guaranteed prophecy, right? It's a statistical constraint. Sure, we have the technology to destroy ourselves tomorrow, but we also have the capacity to choose otherwise. So are we destined to be just another brief flash in the galactic pan, taken out by the great filter of climate change or rogue AI? Or will humanity be the rare exception that survives long enough to finally break the silence of the Milky Way? That ultimately is entirely up to us.